Hi everyone, my name is JTC. Today I would like to talk about one of the latest welding technique in manufacturing industry, which is known as laser beam welding. So, what is laser beam welding? Laser beam welding is a technique in manufacturing whereby two or more pieces of material, which is usually metal, are joined together through use of laser beam. So this is a welding process which produces coalescence of materials with the heat obtained from the application of concentrate coherent light beam impinging upon the surface to be joined. So this is typically calculated in milliseconds for the laser beam pulse. So this laser beam will will have the highest energy concentration, a source of electromagnetic energy or light that can be projected without diverging and can be concentrated to a precise spot. And the beam is usually coherent and of a single frequency. So there are three types of laser, which are gas lasers, solid state laser, and also fiber laser. So what is gas laser? It uses mixture of gases as laser medium to produce laser. So some of the examples are nitrogen, helium, and also carbon dioxide gases. So so it is the most conventional gas laser medium used because it is cheaper compared to the other types of laser medium. So the second one is solid state laser. Solid state laser uses several solid media such as synthetic ruby crystal, neodymium in glass, and also neodymium in yttrium aluminum garnet as the laser medium to produce laser. So the last one will be fiber laser, and this type of laser medium will be optical fiber itself. So now let's talk about the characteristic of laser beam welding technique and also its related applications. So as so we can know that the power density of laser beam is very high, which is in order of 1 milliwatt per centimeter square. So due to this high energy density, it has more heat affected zones, causing that it has high rate of heating and cooling. So the laser beam produce are coherent, which have been same phase and also monochromatic, which comprises of same wavelength. It is usually used to weld smaller size spot, and but the main thing is the spot size can be varied from 0.2 mm up to 13 mm. So you can see that the depth of penetration of this laser beam depends upon the amount of power supply and also the location of the focal point. It is proportional to the amount of power supply. So focal point is also another factor that affect the depth of penetration. So when the focal point is kept slightly below the surface of the workpiece, the depth of penetration is maximized. So pulse of continuous laser beams are used for welding. So thin materials are welded by using millisecond pulses, and continuous laser beam are used for deep welds. It is a versatile process because it is capable of welding carbon steels, stainless steels, high-strength low-alloy steels, aluminum, and also titanium. Due to its high cooling rate, the problem of cracking will be arises when welding high carbon steels. So it is undeniably that it produces high quality weld, and this process is more popular in automotive industry. So now I would like to explain about main components of laser beam welding machine. So this laser machine is a machine that they use to produce laser for welding. So there are few main components of laser machine will be explained later. So the first part is power source. So in this compartment, a high voltage power source will be applied across the laser machine to produce laser beam in its lasing medium. Such as I explained before this, such as gas laser, solid state laser, and also fiber laser. So the second part will be CAM. So what is CAM? CAM is computer aided manufacturing. So this is the in which the laser machine is integrated with the computers to perform welding process. So all this controlling action will be controlled by CAM, so it will speed up the welding process to a greater extent compared to manually control. So the other part will be CAD, will be known as computer aided design. So it is a program similar to CAM. It will be used to design the job for welding. So So the computer will be used to design the workpiece that we desire and also how the welding process will be carried out. So the last one will be shooting gas. So shooting gas will be used during the welding process will in order to prevent from this oxidation. So I guess everyone will be wondering how does the laser beam welding machine works. So as we can see, the ruby crystal is one of the component of this laser beam machine. So it indicates that it uses a solid state laser as the source of the laser. So we can see that the setup of this machine will be setup of this machine at the desired location in between two metal pieces to be joined is done. So after this setup, a high voltage power supply is applied on the laser machine, exciting the laser such that electrons help within the atoms are elevated temporarily to higher energy states. So after that, the electrons held in this excited state cannot remain there indefinitely and drop down to a lower energy level. So in this process, the electrons lose their excess energy gained from the pump energy by emitting a photon. This will be known as spontaneous emission, and the photons produced by this method are the seed for laser generation. So photons emitted by spontaneous emission eventually strike the electron in the higher energy state, which occurs in the lasing medium. So this incoming photon knocks the electron from the excited state to a lower energy level, creating another photon. So these photons are coherent, meaning that they are in phase of the same wavelength and traveling the same direction. So this will be called as stimulated emission. So we can see that most of the photons will be traveling in the same direction, providing that there are some opposing direction of photons, which is knocked by other photons as I described just now. So So photons are emitted in all directions. However, some travel along the laser medium to strike reflecting mirror to be reflected back through the medium. So the reflecting mirror here, so we can see here, define the preferential amplification direction for stimulated emission. So in order for the amplification to occur, there must be a greater percentage of atom in the excited state than the lower energy levels. So this population inversion of more atoms in the excited state leads to the conditions required for laser generation. So the focus spot of the laser is targeted on the workpiece surface, which will be welded. So yeah, this is the weld area on these two metal workpiece. So at the surface, the concentration of light energy converts into thermal energy. So this heat will cause the surface of the material to melt, which progresses through the surface by a process called surface conductivity. So in this case, cam will be used to control the motion of laser and workpiece table during the welding process. So the beam energy level is maintained below the vaporization temperature of the workpiece material. So what is the ideal thickness of this material? So as we know, the ideal thickness to be welded should be less than 20 millimeter. So the energy will be the laser concentrated laser, which is an advantage added when working with materials that have high thermal conductivity. So now I'd like to show a video which is a steel tube chassis construction using laser beam. So let's check it out. So these are the steel tubes which are to be which is to be constructed. So these are the large laser cutting machine which is fully automated. So we can see that there's an assembly of this metal compartment which is yet to be welded later with laser beam. So now I would like to talk about the advantages of this laser beam welding technique. So firstly, it produces high weld quality, and secondly, this is a technique whereby it can be easily automated with robotic machinery for large volume production, as you can see in the video that I presented just now. So there's no electrode required, no two ways required, because it is a non-contact process. So the time welding the time to weld a thick material is reduced compared to the other conventional welding technique. It is capable of welding in those areas which is not easily accessible. So it has ability to weld metals with similar physical properties. So the most important advantage of LBW is that it can be welded through air and no vacuum is required compared to electron beam welding, which uses X-ray. So of course X-ray shooting is also not required. So LBW laser beam can be focused on small areas for welding due to its narrower beam of high energy. So wide variety of materials can be welded by using this technique. So it produces a weld of aspect ratio with there's depth to width ratio of 10 to 1. However, there are also some disadvantages whereby it requires high initial and maintenance costs. So as I explained just now, the cracks may be produced in some metals due to high peak rate of cooling. So one of the example of this kind of metal will be high carbon steel. So in order to operate this machine, so we need high skilled labor and also officer to perform the operation of this kind of machine. So the welding thickness is also limited to not more than 20 millimeters. So this is one of the main constraints whereby this technique cannot be used to weld thick wall materials. So and last thing is the energy conversion efficiency is very low, so which is usually below 10%. So meaning that if you give input of 100 watt 100 watts of power, so at the end you might get maybe like 7 to 8 watts. So it is a very high energy consumption welding technique. So that's all for my explanation on laser beam welding technique for today. Hope you guys will understand more about this welding technique, and hope you guys enjoy this video. Thank you.